All right, let's look at the useful power series. All right, so remember that we had the Maclaurin series in calculus, and we're going to use that to find power series for some basic functions. All right, so here's a Maclaurin series. It's if f of x can be written as a summation, n goes from 0 to infinity, and you have nth derivative of f evaluated at 0, since it's a Maclaurin series, and over n factorial, then x to the n. Alright, so e to the x is a nice function because here, if you set f of x is equal to e to the x, and remember that any derivative of e to the x is actually still e to the x. And so since we're evaluating at the 0, so we have nth derivative of f at the 0 is e to the 0, which is 1. Right? So nth derivative of f at 0 is going to be always 1. So that's why you're going to get the summation x to the n over n factorial. So e to the x can be written as, right, n goes from 0 to infinity. All right, so this is 1, so you have just x to the n over n factorial. So it's going to look like this. So it's going to be 1 over 0 factorial and plus x over 1 factorial plus x squared over 2 factorial, and so on. All right. And another one is a 1 over 1 minus x. This comes from a geometric series. So if you have a geometric series, summation n goes from 0 to infinity, a r to the n, the sum is going to be a over 1 minus r, right? So if absolute value of r is less than 1. So in this case, so we can match them up. So in this case, let's see, r is equal to x and a is equal to 1, right? So which means that we're going to have a summation n goes from 0 to infinity, right? So a is 1, r is x, so you're just going to be x to the n. So which is going to look like a 1 plus x squared plus x cubed, and so on. All right, and so this is going to add up to 1 over 1 minus x if absolute value of x is less than 1. All right. And the cosine of x, sine of x can be found using the same technique, Maclaurin series, and it's going to come down to this. So you have a summation, n goes from 0 to infinity. All right, so since cosine goes up and down, it's going to be alternating, so negative 1 to the n. And cosine is an even function, so you have x to the 2n over and 2n factorial. All right, sine is very similar, except that the sine function is an odd function. So what we have is still alternating, so it's negative 1 to the n, but it's going to pick out all the nth power terms. So you have 2n plus 1 over 2n plus 1 factorial. All right. And the hyperbolic cosine and hyperbolic sine are very similar to cosine and the sine, except that it's not alternating. So hyperbolic cosine, you're going to have a summation. N goes from 0 to infinity. And then you have a x to the 2n plus 1 over, actually, sorry, it's a odd one. It's just going to be 2n, so it's going to be an even one. Then you have a 2n factorial. Hyperbolic sine is going to be a summation. N goes from 0 to infinity. And x to the 2n plus 1 over 2n plus 1 factorial. Right? So those are the useful power series, and if you have these functions, we should be able to come up with the power series, or if you see the power series, then you should be able to recognize the functions. All right, that's it. I hope that this was clear.